Dear students, today's class let us discuss about the aldehydes, ketones and carboxylic acids. In the previous video, we have discussed about what do you mean by aldehydes, what do you mean by ketones and what do you mean by carboxylic acids. So, here one of the group is common functional group, we can say that. So, which is the group is common in all aldehydes, ketones and carboxylic acids? The carbonyl group is common in all the three functional groups. So, now let us consider, so what is the structure of carbonyl group? Why? Because that carbonyl group is present in aldehydes, ketones and carboxylic acids. So that now let us consider the group of, that is a carbonyl group, functional group, how it is the structure. So structure can be considered as, here carbon atom having double bond oxygen. So and this carbon atom is having remaining two valencies or free valencies. Those two can be satisfied by either hydrogen atom or any alkyl group. So if it is satisfied by one hydrogen and one alkyl group, it becomes aldehyde, and both the valencies are satisfied by hydrogen, it becomes aldehyde. Whenever both the valencies are satisfied by any alkyl group or aryl group, then it becomes a ketone. Whenever this one valency of this carbon atom is satisfied by one alkyl group and another valency is satisfied by hydroxyl group, we can say that it is an carboxylic acid. So this is the common functional group in all the three functional groups. Now what is the hybridization of this carbon atom? What is the hybridization of this carbon atom? This carbon atom hybridization is sp2. So why? Because it consisting of three atoms are connected by this carbon atom. This carbon atom is connected by oxygen. This carbon atom is connected by any other hydrogen or alkyl group. This also connected by any hydrogen or alkyl group. So this carbon atom is connected by three atoms. That's why there may be the presence of three hybridized orbitals. That is one s orbital, another two p orbitals can be seen. So here, how does the structure, how can you explain the hybridized structure of carbonyl group? So this is sp2 means, here sp2 means there are three orbitals can be seen, three orbitals can be seen. So these three orbitals, by the mixing of these three orbitals, we can able to obtain an carbonyl group. So here, when we consider the carbon atom, this carbon atom is having one orbital, and oxygen atom is having one p orbital, and this is having one orbital, it is having one orbital. This carbon atom is having three hybridized orbitals. One is s orbital, another is two p orbitals. By mixing of one s orbital and two p orbital, we are going to get three hybridized orbitals which are having equal energy and shape. So here what happens, by the overlapping of this carbon atomic orbital and oxygen atomic orbital, there is a formation of an axial overlapping takes place, that leads to the formation of an sigma bond can be seen. So here also it can also be overlapping with any hydrogen atom or any alkyl group of the carbon atom of p orbital carbon atom can overlap. It can also possess axial overlapping, it can also possess axial overlapping. It leads to the formation of sigma bond. Here also it leads to the formation of sigma bond. In this carbonyl compound, there are three sigma bonds are present and one pi bond is present. This is sigma bond, this is pi bond. This is sigma bond, this is also sigma bond. Always single bonds, it carries sigma bond. Double bond, if there is a presence of one double bond, one will be sigma bond, another will be pi bond. One bond is formed by the axial overlapping, another bond is overlapping by sideways overlapping or lateral overlapping, that leads to the formation of pi bond. Here, what we are observing here, this carbon atom is having three hybridized orbital. One is hybridized overlapping with oxygen atom. Oxygen atom is highly electron density, so higher electron density can be seen. It forms sigma bond. This carbon atom can also be overlapping with any other hydrogen or alkyl group of carbon atom, that leads to the formation of another two sigma bonds. So three sigma bonds are over. One more pi bond is there. That pi bond is formed by the sideways overlapping of carbon p atomic orbitals with oxygen p atomic orbitals. Here the outermost valency of this carbon is p atomic orbital. So we can observe the p atomic orbital is present in carbon. Here also there is a presence of an p atomic orbital in oxygen. by sideways overlapping of this oxygen and carbon that leads to the formation of n pi bond. The one orbital is above the plane and another orbital is below the plane. So two are above the plane and another two are below the plane. So due to overlapping of carbon p atomic orbitals with that of oxygen p atomic orbitals, which will undergo lateral overlapping between carbon and oxygen, that leads to the formation of n pi bond. That leads to the formation of n pi bond. Here carbon is there, carbon, as usual sigma bond is there is a formation of sigma bond, and there is a pi bond is there. Due to lateral overlapping there is a formation of pi bond, due to axial overlapping there is a formation of sigma bond. This is an sigma bond, lateral axial overlapping, this is pi bond, that is sideways overlapping or laterally overlapping. This is weak bond, pi bond is weak bond. Next is oxygen is there, here as usual oxygen is there. Next, here one orbital is there, here it can form one bond with any hydrogen or carbonyl group, here also it can form one bond, that is either it may be bonded with a carbon atom of any hydrocarbon group or any hydrogen atom. If there is a presence of hydrogen, we can say that hydrogen is 1s1. 1s1 means it is an axially overlapping takes place, that leads to the formation of sigma bond. Sigma bond will form between carbon and hydrogen. Here also carbon p atomic orbital axially which undergo overlapping, that leads to the formation of a sigma bond. This is the structure. So what is the geometry of this structure, how it is looks like? This geometry of this structure is considered as trigonal planar. Trigonal planar is the geometry of this molecule. So because if you consider carbon atom, here another two valence are satisfied by any other hydrocarbon group or hydrogen, and here also oxygen. So this oxygen carbon there is a formation of double bond. So when we consider the planar structure, so this leads to the formation of trigonal. This leads to the formation of trigonal. So due to that reason, this is the geometry of this molecule is considered as trigonal geometry. Trigonal geometry. So when which undergoes sideways overlapping, there is a formation of n pi bond can be seen. So this is about the formation of sp2 hybridized orbital. This is the structure of carbonyl group. So this structure will be present in all the cases of aldehydes, ketones and carboxylic acids. These two are satisfied by any other groups, as I told you in the last class itself. So when we consider the aldehydes, ketones, carboxylic acids, there will be presence of carbon double bond oxygen is mandatory in aldehydes, ketones and carboxylic acids. Compulsory there must be presence of carbonyl group in aldehydes, ketones and carboxylic acids. Whenever if you write in carbon bond oxygen, whenever if there is a presence of carbon bond oxygen, single bond is present between carbon and oxygen, then such type of compounds are always called as alcohols. Always called as alcohols. Here there is no presence of double bond between carbon and oxygen, that's why it becomes alcohol. That's why it becomes alcohol. Whereas in case of carbon and oxygen, between carbon and oxygen, if there is a formation of double bond, then we can say that it is a carbonyl group. Carbonyl group, it may be considered as aldehyde or ketone or carboxylic acids or esters or ethers, esters. It may be also considered as anhydride ester and also the ester amine. So these are all the considered as the carbonyl group compounds. Here in case sometimes carbon C6H5O, here C6H5, this is in benzyl group. Benzyl group is nothing but like this. If it is having oxygen, carbon oxygen is single bond and it should be always phenol. It should be maybe phenol and also ethers. In the previous class we have discussed CH3O CH3 dimethyl ether. So here also oxygen is bonding with carbon. Here also single bond is there. If it is a single bond, either it may be alcohol or phenol or ether. If it is in double bond between carbon and oxygen, it must be carbonyl group. It may be in the form of aldehydes or ketones or carboxylic acids. Okay, now let us go for the nomenclature of aldehydes, ketones. So let us take nomenclature of aldehydes and ketones. After the discussion of aldehydes and ketones, let us go for the carboxylic acids. So nomenclature of nomenclature of aldehydes and ketones. Nomenclature of aldehydes and ketones. So how do you name for the some different aldehydes and different ketones? So in nomenclature of aldehydes and ketones, we can name two kinds of names we can represent. So one is common name, another one is IUPAC name. So what is the difference between common name and IUPAC name? The common name is nothing but the different kinds of aldehydes and ketones from which we are extracting the aldehydes and ketones. That extracted source name itself is called as the common name. Whereas in case of IUPAC name, so International Union of Pure Applied Chemistry, that is a committee which has possessed some rules. So based on those rules, if you identify the name of the structure or compounds or organic molecules, then such type of molecules are nothing but the IUPAC names, we can say that. Now let us identify some different formulas with common name and IUPAC name. So how do you write the common name for aldehydes and ketones? So whenever in carboxylic acids, in a common name, so in common name of aldehydes, common name of aldehydes. So how do you write the common name of aldehydes? Very easy, very simple. Whereas in case of carboxylic acids, in case of, for example, HCOOH, it is an carboxylic acid. The name of this molecule is formic acid. Formic acid. So here formic acid is the name of this carboxylic acid. So aldehydes can be named by the replacement of IC acid, replacement of IC in carboxylic acids by replacement of IC acid by aldehyde. That gives the common name of an aldehydes. For example, here IC acid is replaced by aldehyde. That is the common name of some different aldehyde molecules. For example, here what happens? IC acid is replaced by what? Aldehyde. This can be replaced by aldehyde. So it is as usual. What is the name of this molecule? It becomes formaldehyde. So when HCHO, if it is present, this becomes formaldehyde. This is formaldehyde. This is formic acid. So like that. Here acetic acid, CH3COOH is the acetic acid. So here OOH is there. That's why OIC IC is replaced by, if it is a presence of COOH group, then we have to write ic acid. If it is not present, instead of this CH3CH aldehyde group is present, then what we have to write for this name is acetic acid. Acetic acid is the name of this compound. Whereas in this molecule, how do you write? This is an acid. Ic acid is replaced by what? Here ic. IC acid is replaced by what? So here it is same. Acid. IC acid is replaced by what? Here instead of COH group, there is a presence of CHO group. That's why CHO group is what? Aldehyde. CHO group is what? Aldehyde. That's why aldehyde we have to write. What is the name of this molecule? Acetaldehyde. Acetaldehyde is the common name of this molecule. So these are all the some common names of these molecules. Common name, how do you write the common name for the aldehydes? By replacing the ic acid from carboxylic acids by aldehyde. So here carboxylic acid, if it is there, formic acid it will form. IC acid is replaced by IC acid is replaced by aldehyde. That forms CHO group is aldehyde. That forms formaldehyde. This is acetic acid. Acetaldehyde. Ic acid is replaced by aldehyde. Acetaldehyde. These are all the common names of these aldehydes. So similarly, how do you write the common names of ketones? Here common names of ketones. So how do you write the common names for the ketones? So here in ketone, common names can be written based on the alkyl groups present either side of the carbonyl group. For example, here R C double bond O R dash. It is one alkyl group, it is another alkyl group. So two alkyl groups are different alkyl groups. So based on the presence of alkyl groups, we can name it alkyl aryl ketone or alkyl ketone. So whatever it may be the compound. For example, R is replaced by CH3, C double bond O, CH3. So how to write the common name for this compounds? Common name for this compounds is, this is methyl, this is methyl. So alkyl ketone is the common name for the ketones. Alkyl means first we have to say alkyl group name, after followed by carbonyl group. This is methyl, this is methyl. Dimethyl, both are same groups are there, that's why we can use the dimethyl. This is ketone. Dimethyl ketone is the name of this molecule. If it is like this, C2H5, C double bond O, CH3. So how do you name the common name for this molecule? Common name for this molecule is, here ethyl group is there, here methyl group is there. Which one will come first, ethyl or methyl? E, alphabetically E will come first. That's why this is ethyl methyl ketone. So alkyl ketone. So alkyl ketone is the common name for the any kinds of the ketones. We may say that. Alkyl aryl ketone. We can also say that alkyl aryl ketone. The common name for this is C double bond O R. Here alkyl, this is aryl. This is alkyl group, this is aryl group. Alkyl aryl ketone. This is the common name of this molecule. So that's why so many number of compounds can be write their common names for the aldehydes and also as well as ketones. So then how to write the IUPAC nomenclature for the aldehydes and ketones? So this is about the common names for the aldehydes and ketones, whereas in case of IUPAC nomenclature, we must apply some IUPAC rules. Based on those IUPAC rules, we must represent the correct name of the aldehydes and ketones. So these formulas or these rules we have discussed in the first PUC syllabus itself. So some basic concepts of chemistry, organic chemistry, there we have learned about the rules of IUPAC nomenclature. So let us discuss the IUPAC names of aldehydes and ketone molecules. Now let us consider some important formulas of the aldehydes and ketones, and let us write some important common name and IUPAC name. So already I told you that how to write the common name for the aldehydes and ketones, and similarly, so what are the rules we need to follow to write the IUPAC nomenclature of these aldehydes and ketones. Now let us consider the first compound, HCHO. What is the common name of this molecule? The common name of this molecule is formaldehyde. What is the IUPAC name of this molecule? The IUPAC name of this molecule is methanol. So to write the IUPAC nomenclature of these molecules, we have to use some suffixes. So what is the suffix used for this aldehyde? So for aldehydes, the suffix is, for aldehyde the suffix used is al, all, and for ketones the suffix used is on, one, on. For carboxylic acid, oic acid. Okay, now we are discussing only aldehydes and ketones. So for aldehydes, what is the suffix we are using? For aldehyde we are using the suffix in IUPAC nomenclature is al, that is methanol. Why? Because carbon atom is only one carbon atom is there. For word root for the one carbon atom is methane, or methane, E is replaced by Al, that is the suffix methanol. So what is the second formula? CH3CHO. This is called acetaldehyde. Acetaldehyde is the common name of this molecule. What is the IUPAC name? This is number 1, this is number 2. So carbonyl carbon atom we have to consider while assigning the numbers. This is number 1, this is number 2. What is the word root for this? Ethane, ethanol. So aldehyde is there. So ethanol, NaL, all, ethanol. Okay, or aldehyde also we may use. So third formula is C6H5CHO. What is the name of this molecule? C6H5CHO. C6H5 is phenyl group. To this phenyl group, one hydrogen atom is replaced by one functional group, that is aldehyde functional group. What is the common name for this is? So directly we can say that benzaldehyde. Aldehyde. Benzaldehyde is the name of this molecule. The IUPAC name also we may consider benzaldehyde. It is also called as benzaldehyde. Also, one more name for this is phenyl methanol. This is the formula is phenyl. So one carbon atom is there. Phenyl methanol. The IUPAC name is phenyl methanol. Phenyl methanol is the IUPAC name of this molecule. Benzaldehyde or either phenyl methanol or R. You can also write phenyl methanol. Next formula is this is CHO, CH2, 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 CH3. How many carbon atoms are there? 1, 2, 3, 4, 5 carbon atoms are there. So what is the name of this acid? So Weller-aldehyde is the common name. Weller-aldehyde is the common name of this molecule. What is the IUPAC name? 1, 2, 3, 4, 5. What root is 5? That is pentanol. Where is functional group? At what first position? That's why pent1-ol or pentanol also we may write. IUPAC name for this is pentanol. Pentanol is the IUPAC name. So next is ketone. CH3CO, CH3. What is the common name? Here for ketones, while writing the common name, we have to consider the alkyl groups. Alkyl ketone is the common name. Alkyl group is what? Methyl. Here also methyl. We can use the prefix di. Di can be used. Why? Because both are the same groups. Dimethyl ketone is the common name of this compound. Dimethyl ketone. What is the IUPAC name? IUPAC name is here 1, this is 2, this is 3. For the second position, carbonyl group is present. That's why propane to all. That's why propane is replaced by to all, to on. Why? Because it is ketonic group. Remember, C double bond O. This is ketonic group. So for ketone, suffix is on. That's why propane to on or 2-propanone also we may pronounce it. So next is this is the molecule. Here is the carbonyl group. So how do you assign the numbers? While assigning the numbers, we have to consider the functional group is which is nearer to which end, either this end or this end. Here 1, 2, 3, it is too long. This is 1, 2, it is very near. That's why 1, 2, 3, 4, 5. This is the assigning the numbers. What is the common name for this is? This is what? This is propyl. This is methyl. P will comes first. Propyl methyl ketone. So the common name for this is propyl methyl ketone. So what is the IUPAC name for this compound? This is IUPAC name is 1, 2, 3, 4, 5. Pentane to penttuone. Simply pent is the word root. Second carbon atom having carbonyl group 2-one. That is pent-2-one is the IUPAC name. What is the IUPAC name for this molecule? C6H5COCH3. So the IUPAC name of this molecule is this is acetophenone is the common name. Acetophenone is the common name. So IUPAC name is also considered as same as like common name. Acetophenone. Acetophenone is the common name and also as well as IUPAC name. The next molecule is CH3 twice, CHCO, CH3 twice. So what is the molecular formula? Clearly we may represent this is CH3 twice, means that this is CH3. You just consider this CH, C double bond O, CH. Here CH3 twice is there. Here CH3. For this one more CH3. Okay. Here CH is there. To this CH3 twice are there. Here one CH3. Here one CH3. So what it becomes? So this is CH3 CH. For second position methyl is there. Here also for third, fourth position methyl is there. This is 1, 2. This is 3, 4. It is 5. So we have to assign like this. So what happens? This is the carbonyl group. This is the carbonyl group. So what is this? and what is this? While writing the common names, we have to represent alkyl ketone. What is the alkyl group? It is, so for middle carbon atom, it is substituted to the carbonyl group. That's why we can consider isopropyl. How many? It is also isopropyl. Here both are isopropyl. Why? Because that's why both are same, are the alkyl group. That's why we may use the prefix, that is di. So what is di? How many di are there? Di means 2 are there. What are there? Isopropyl, it is also isopropyl. Diisopropyl, as we used here, dimethyl. Why? Because both sides are methyl groups are there. That's why here also both sides are isopropyl are there. That's why how many are there? 2 are there. That's why diisopropyl ketone. Diisopropyl ketone is the name of this ketone. What is IUPAC name? Here 1, 2, 3, 4, 5. So for third position, carbonyl group is present. For second position, methyl group is present. Here also for fourth position, methyl group is present. First we have to write the substituents, methyl groups. Next we have to write word root. Next we have to write carbonyl, that is functional group, that is suffix. 2, 4 dimethyl. The IUPAC name is 2, 4 dimethyl. 2, 4 dimethyl. This is pentane is the word root. Pent-3-on. Pent-3-on is the IUPAC name of this given compound. So similarly, we may write the number of organic compounds. We may write like aldehydes and ketones, and we may assign the respected common names and also as well as IUPAC names. Okay. Dear students, now let us consider some IUPAC and common names for the cycloalkanes. So still now we have discussed about the common names and IUPAC names for the aldehydes and ketones for aliphatic compounds. Whereas in case of aromatic compounds, so except this one, in case of cyclic and aromatic compounds, so how to write the common name and IUPAC name? Not only for the aliphatic compounds, or aldehydes and ketones are present. In case of aromatic compounds also we can observe the aldehydes and ketones, so that how to assign the IUPAC nomenclature and common names for such kinds of compounds. Now let us consider, so whatever it may be the cyclic compound, while assigning the numbers we have to take care. So from what side we have to assign the number? So whatever it may be the compound, if there is a presence of carbonyl group, here this is the carbonyl group. So this carbonyl group linked carbon atom is always considered as 1. Carbonyl group linked carbon atom in cyclic compound, the carbonyl group carrying or linked carbon atom is always considered as 1. So next this is 2, this is 3. Why? Because this is very nearer, this group is very nearer to this functional group. That's why if you go like this, it is too far. So that's why we should not go like this. So always we have to assign the numbers like this. This is very short way. So always we need to choose and short way to reach our goal. That's why it is very easy to reach the another substituent. That's why this is 1, this is 2, this is 3. So suppose if you consider this is an 1. Is it possible to 1? No. It is highly impossible to consider the number 1 for this carbon atom. So carbonyl group is here. That's why carbonyl group of the carbon atom, linked carbon atom is considered as carbon atom number 1, and we should not go like this. We have to go like this. So this is the carbon atom number 1. Next this is 2, this is 3. So okay. While assigning the common names, we have to write artha, para and meta, or alpha, alpha dash, beta, beta dash we may represent. So here what happens? This is carbonyl carbon atom, next carbon atom is alpha, this is beta, this is gamma. This is substituted to the gamma position. So or else we may consider this is para, this is artha, this is meta. So in common name, this is meta methyl cyclohexane carbaldehyde. The suffix for the cyclic compounds. In cyclic compounds, for the aldehyde, we may use it as aldehyde is an carbaldehyde. So aldehyde suffix, aldehyde group is used as carbaldehyde. Carbaldehyde is the suffix. So what is the suffix for the aldehyde group in aromatic or cyclic compounds? Means the suffix is carbaldehyde in aromatic or cyclic groups. So this is meta-methyl cyclohexane carbaldehyde. Cyclohexane is replaced by carbaldehyde. cyclohexane carbaldehyde is the name of this molecule. The next is, what is the name of IUPAC name of this molecule? Where the carbonyl group is present? Here the carbonyl group present in the form of aldehyde. This is assigned as number 1, this is number 2, this is number 3. So what is the IUPAC name and common name for this molecule? So how do you assign the common name and IUPAC name? So here this is one carbon atom that is considered as carbonyl group. Next 2, next 3, here the substituent as like alkene group is present. In, we may use suffix it as in. So where it is at the second position of the carbon atom. That's why the word root for this molecule is 1, 2, 3, prop. That's why we may write propane. Propane. E is replaced by what? E is replaced by 2-ene. For the second position, ene is present, and also as well as for carbon atom number 1, all is present. All is nothing but aldehyde group is present. 2-ene all. Directly we may write like this. Propane 2-ene all is the IUPAC name of this molecule. Next, let us go for the one more molecule, that is benzene dicarbaldehyde. This is carbon atom number 1. Always I told you that. So either you may consider this is the carbon atom number 1 or this is the carbon atom number 1. Any one you may choose. Why? Because both are similar groups. Here also aldehyde, here also aldehyde. Both the carbonyl group contains. Carbonyl group carrying carbon atom, containing carbon atom linked to this carbon atom. That's why we may consider 1. Next is becomes 2. If it is 1, it will becomes 2. Okay, this is 1, 2. So what is the name? Benzene 1, 2 dicarbaldehyde. 1, 2 dicarbaldehyde. 1, 2 dicarbaldehyde is the name of this molecule. Similarly, we may consider one more molecule, that is this is the carbonyl carrying carbon atom is 1, this is 2, this is 3. So what is the common name and IUPAC name of this molecule? The common name is, this is para, this is ortho, this is meta. This is meta bromo benzaldehyde or benzene carbaldehyde also we may pronounce. Benzene carbaldehyde or benzaldehyde. So IUPAC name of this molecule is, the IUPAC name of this molecule is, so here 3 is the bromo group is substituted. 3 bromo benzene carbaldehyde or 3 bromo benzaldehyde also we may consider. This is 3 bromo, this is entire molecule is considered as benzaldehyde. That's why 3 bromo benzaldehyde is a molecule. Or here I have considered carbaldehyde. Either we may replace by carbaldehyde or benzaldehyde. Both are the correct formulas. So this is all about the common names and IUPAC nomenclature for the considering aldehydes and ketones. In the next concept, let us discuss about the carboxylic acids. There also we are discussing about the IUPAC names and common names of these compounds, and also next class let us go for the discussion of important preparations of aldehydes and ketones. So what are the important preparations of aldehydes? There are many common names, that is named reactions are there for the aldehydes. So what kinds of named reactions are there? There are Stephan reaction and Rosemond reaction and Aldehydes reaction, and one more is Aldehyde reaction. So these are all the common names for the preparation of aldehydes and ketones. So those important reactions let us cover in the next video. Thank you.